All right, this is lesson 5-6, graphing inequalities in two variables. So one of the things we're going to be doing is we're going to be using a coordinate graph again, and we're going to be getting a boundary line drawn, and then we're going to be shading on one side or the other of the boundary line. So one of the important things is sometimes the boundary line has numbers along it that do not count for the solution, so that means it's a dashed boundary, and then sometimes it's going to be a solid because those points also count as part of our solution area. So the way you can tell is if you just have less than or greater than to dash the boundary, but if you have the inequality symbol that also has the equal sign with it, then it's a solid boundary. So that's one of the important things we're going to watch for as we're working through. Alright, so our first example, we're going to graph 3x minus y is less than 2. Now what I'd like for you to do is to do your boundary line, and I'm going to label mine so there's no chance you'll get confused on what I'm doing. But the first thing I see is that I have a less than, so that tells me that, hey, my boundary line is going to be dashed, and I'm going to write that down, so that's one of the things when I'm graphing I'll look back at. Now as I'm graphing, I've got 3x minus y, and I'm going to just change it to equals while I'm doing the boundary line itself. That way I won't get confused and use any of this work in later parts of this work area that I have to create for this. So what I'm going to do is I'm going to take the 3x and I'm going to transport it across the equal sign, and I'm going to have negative y equals, remember when it transports across it changes sign, so it's negative 3x plus 2. Now because this is negative y, change all your signs across your equation, so y equals positive 3x minus 2. Now remember our slope is the number in front of x, just the number. So it's 3, so when we're graphing we use it 3 over 1. Remember our y-intercept is this number out here that doesn't have the variable, and that's negative 2. Remember this is where we cross the y-axis. So when we start our graphing, we're going to go to the y-axis to negative 2, and we're going to put our mark that our line is going to go through this point, and then we're going to use our slope to find the actual slant of the line. So from this point we're going to count up 3 and to the right 1, up 3, right 1. We'll do that as many times as we can across the graph. Once we get that direction, then we'll go back to our point where we crossed, and from that point we'll now count down 3 and left 1. So we'll reverse both directions we started with. Now once we get that part finished, then we're going to get our straight edge, and we're going to make sure that we're drawing a dashed boundary line as we're drawing. So you want to make sure you don't have to make your dashes teeny tiny, but you want to make sure that we can tell they're dashed without too big a gaps between them. Okay, they're probably not going to be as tiny as mine. Now I went off my dots just a little bit as I'm trying to explain this to you through the video, but make sure it's really lined up, because what I've really done here is created an area where it's saying there's solutions that there really aren't solutions. So you want to be careful, or I'm excluding sometimes solutions that are supposed to be there. So just for now, just know that I need to go directly through those points, and I need to be very accurate. Now the next step that you need to do is you have to pick a test point. Now the test point can be any point that's not on the line itself. So one good place to test is going to be 0, 0, because those coordinates are easy for you when you're filling in your inequality. Well, let me put my test point over here. Now I'm going to write down what my test point is. I'm going to use 0, 0. The only time I don't use 0, 0 is if I can't tell, my line is so close to it, which side is it really on, because maybe I'm not real accurate, or if my line is definitely going through 0, 0, then I will not use 0, 0. Then I have to pick a different ordered pair, something that I can figure out the coordinates for, and then I can easily substitute in. Now the important thing when you substitute your test point is you've got to go back to this original problem, because if you've used some change to your problem and you didn't get everything correct, it's going to mess up your shading. So go back to the original, and as we're testing it, we're going to fill in the x and y with 0. So instead of 3x, we'll have 3 times 0 minus 0 is less than 2. So on the left this time, everything turns out to be 0 is less than 2. And that's true. So we'll write true here so that I know that my test point was true. That means it's a solution. Now on my graph, sometimes it's a good idea to mark your test point. Since the test point is true, you want to shade the side where the test point is at. If you ever get a false, then you don't want to shade that side. You want to go to the other side where your test point is not at. So then you want to make sure as you're shading that you're getting up next to your boundary line, but make sure that you're not going across your boundary line. Don't go in between your dashes, but make sure you get right up next to it. Now with a good pencil, you can get really close. Now with this board, I can't quite keep it from getting over there, but you need to get up there because everything you color, you're saying is a solution. So notice I should be a little over this way because of the dots. And then you want to make sure that you are giving us shading. You don't want gaps in your shading. So you want to make sure that you do a nice job coloring here. You don't want to leave scribbles. You want to make sure that it's pretty solid. It doesn't have to be very dark, but it has to be where we can tell it's shaded. But if I do this where I leave gaps, then what I'm saying is that the open spots are not solutions. So I'm saying everything that colored is, the things that aren't would not be. So you want to make sure you don't have any big gaps through there. So you want to make sure that you've colored, and if you've got a good wooden pencil and it's sharp, you can lay it to the side and shade pretty quick. Some people that are enrolled in art, they have some quick ways to do some shading that they use in the art world, and that works here also. But you want to do a neat job. You don't want them too terribly dark, because if you make a mistake, you want to be able to erase them easily. If you make any marks over here by accident, then you use your eraser and you erase them, because you only want your solution on the graph itself. Alright, so let's try another one of those. This time we're going to graph y is greater than 1/2 x plus 3. So the first thing I'm going to do is my boundary line. Again, this one is dashed, so I'm going to write that down that I have a dashed boundary. I'm going to, for a minute, just pretend it's an equal sign so that I can see it as a line for a moment. This one, y is already by itself, so the slope is the number in front of x, so it's 1/2, and the intercept is 3. This one crosses the y-axis at positive 3, has a slope of 1/2, so I will go up 1 and right 2, up 1, right 2, up 1, right 2, up 1, right 2. And keep doing that. When you run out of room, go down 1 and left 2. So that you reverse both directions, so you get a nice good line all the way across. Now remember it's dashed because that's what we wrote there, so we'll get our dashing tool here. And then we'll try to line it up a little better this time. We'll dash our line all the way across our graph. Alright, I've done a little better job getting through my points this time. Now again, my line is not going through 0, 0. So this is a really good test point whenever it's open. So 0, 0. So our test point, let me get back to a solid line here for writing. Our test point, and I do want you to write down your test point, because if you use something different, it's going to make a difference if you don't name it correctly. It's good to mark the test point you're trying to use in case you make a mistake naming it, then I can figure that out for you. So remember, go back to the original problem when you test. So we're going to use y is greater than 1/2 x plus 3. Since our coordinates are 0 and 0, we'll change the y to 0 and the x to 0. And then we're going to simplify. This side is 0 greater than, this would be 0 plus 3, which is 3. Is 0 greater than 3? And that should be false. So you'll write false beside here. That means the test point's not a solution, and anything over here with it would not be a solution. So this time you want to go up above the line, and you want to do your shading up here. So you're, again, remember, you're going to shade up to, but not over or between the dashes. I'm getting off there just a little bit. You want to do some good shading over here. You don't want any open gaps. Doesn't have to be real terribly dark. I forgot to switch over to the highlighter so it looks a lot darker this time. But up to the boundary line, you can do this really neat on your paper. Doesn't have to stay in the squares, because remember that side of the graph goes on forever in all those directions, so it doesn't have to be a nice neat square corner up there or anything. Okay, so there's how you graph your inequalities into variables. All right, we'll try one that might get to be just a little bit different. This one we're not going to do right now, but what I want you to notice here, if you look right there, that's going to be a solid boundary this time on that one. But what I want to take a moment, so I don't run out of time here on the time that's allowed on these clips, is I want to talk to you about what if you don't have an X? How do you graph this? That means your boundary line is either horizontal or vertical. So if there's no X, what happens? The first thing we see is it's solid. The second thing is if I'm looking at y equals 4 and there's no x, I can't ever cross x. So on the y-axis, I go to 4, put my mark, and the only way not to cross x is to make this a horizontal line. So I'm going to write over here, abbreviation that I know it's horizontal. Now, it's going to be a solid line, so when I'm drawing my line, I'm going to draw a regular line this time. Okay, I don't want any dashes or anything like that in there. So I want to make sure I just draw and use a straight edge so you get very accurate across there. Now, when you go to use your test point, you absolutely can use a test point, but you wouldn't have to. You really could think this one out. But let me show you if you use a test point. Again, we could use 0, 0. So this is our test point. Change the y to 0. You don't have any place for the x, so just look at what y is on whatever point you want to use. So 0 is less than or equal to 4. That's true. 0 is less than 4. That means, and I'm not going to shade all the way, but you would do all your shading down this direction. Now, you could probably see that without a test point when you don't have an x, because y has to stay littler than 4. It's got to be below that boundary line that's drawn there. Okay, another similar situation is if you don't have a y but you have an x. So when you do the boundary line on this one, I've set this up to be a dashed boundary. When we're looking at x minus 2 equals negative 3 for the boundary, we're going to add 2 to both sides and we'll have x equals negative 1. There's no y here, so that means this is the only kind of line that starts on the x-axis. Go to negative 1 on the x-axis. But this has to be a vertical line. Now remember, it's a dash, so we're going to make sure that we dash in our boundary here. And again, go with your ruler straight up and down so you can make your dashes fairly quickly as you go across there. Now my tool quit working partway through, but you get the idea. It would go all the way down there. It's hard to correct on this. So just imagine it goes all the way down completely for us there. Now, again, you can probably think this out, but I would use the test point again. 0, 0 is a good test point. So as you're using 0, 0 here, change your x to 0, but remember, go back up here to the original. 0 minus 2 is greater than negative 3. So is negative 2 greater than negative 3? And that's true when you're looking at your negatives. Negative 2 would be bigger. So you want to color where the test point's at, so that would be this side here as you're shading all the way down. And make sure you do neater shading. I just want to kind of quickly go through and save a little time here with the coloring on this overhead. But you can do some neater shading, and that's what I would expect to see as you're working through. Okay, so there's just some various examples, and practice is probably the best thing. Remember, if you have your boundary line and it does go through 0, 0, or you're not sure which side it's supposed to be on because you're not real sure as far as your points, then you can pick any other point. Just make sure you find the correct x and y value for your ordered pair, and then make sure you substitute the x for x and the y for y, and be very careful there. Alright, so what you're going to practice, you'll need to get some graph paper from me, but you'll get on page 318, 2 through 10, the evens, and then I want you to try numbers 30, 37, and 44.